Hello everyone. In this video, we're going to be solving a non-standard equation with exponentials. We have x equals 2 to the power x minus 2, and we're going to be solving for x values. So I'm going to show you a couple different approaches here. They're very similar though. I don't know if there's another way to approach this problem. Definitely guess and check is a good idea, but one thing that you have to keep in mind is the number of solutions you're going to be getting. You have to guarantee that you're finding all solutions or prove that there are no other solutions besides the ones you found. Anyways, let's get to work. We have x equals 2 to the power x minus 2. Let's rewrite that problem and start with our first method. So for our first method, we're going to go ahead and use a special function called Lambert's W function. Okay? To be able to use that, we're going to need something like this. Let me briefly talk about Lambert's W function. I know some people are divided. Some people love it, some people hate it. I don't know why. I used to hate it too, by the way. Now I understand. When you don't understand something maybe fully, you don't seem to like it. But anyways, so here's how it works. First of all, we're going to get rid of this x minus 2. So my goal is to, if I have an x here, this should also be an x, okay? I want them to be the same. Of course, that's not the end goal. The end goal is getting something like t e to the t. So that when you have a product like this, you have the same exponent as what multiplies that exponential. I hope that makes sense. And when we apply Lambert's W function, which is a special type of function, we get t out of this. So this is called the product log function or Lambert's W. And if you're going to type it up in Wolfram Alpha, that's the word you're going to use. It's just one word, by the way, product log. And then inside the parentheses, you can put whatever you like. In this case, that will be product log of t to the t. Also, there are different branches because if you think about f of t equals t to the t, this function is not a bijection, as you can see from the graph. And there's, I think, a maximum somewhere. And then you can split it up into two pieces such that each piece is a bijection. Then you can take the inverses respectively, so on and so forth. But that's a long story. Let's just get to work. We're going to go ahead and apply it. But this is not ready for Lambert's W because we do need an t, we do need an e to the t. We have none of those. But the first step is going to be to get rid of this minus 2 thing because it's really going to cause an issue. So why don't we just write it like this? This means 2 to the x over 4. We can go ahead and cross multiply. X times 4 equals 2 to the power x. Now, first step, and I want to show you this step by step so you get a good understanding. I know some people complain about it all the time. I don't know why they complain because, I mean, if it's too easy for you, then it's easy for you. That's fine, right? But anyways, some people, you can never please them. So we're going to, since we do want t e to the t, which could turn into x e to the x, right? Could be any variable. We have an x, but we don't have e to the x. But that's okay. Here's one thing to keep in mind. You want to keep the x where it is. You don't want to get something like 1 over x, unless you have something like 1 over x. Let's say you had an equation like this. I don't think it's going to work. But in this scenario, it will be meaningful. And let's just say this is 4x. I don't know which number is going to make it work. Maybe some fraction. But in this case, you would want to write it like this. Bring the x over there so that you can get 1 over x times 2 to the power 1 over x equals 4. Why? Because notice that these two things are equal. That's the whole goal. So now we're going to keep the x. So let's go ahead and actually multiplying by 4 was not a good idea. So why not keep it that way? So let's go ahead and keep the x where it is. But what we're going to do now is divide by this. So it's going to look like this, okay? And of course, you're going to end up with 1 over 4 because this is basically 1 over 4 times 2 to the x. When you divide by 2 to the x, you have 1 over 4 left on the right-hand side, okay? It's still left. So now 2 to the power x is in the denominator, which means we can write it as 2 to the power negative x. Remember the properties of exponents, and that is equal to 1 over 4. Now, we're pretty close to something like x e to the x. But that's not x, actually. Because of this, we're going to have to use negative x. So let's go ahead and multiply. Now, you got to remember this. What was my first step? My first step was to turn this into a division. My second step was to divide both sides by 2 to the x so that I can have the variables on the same side. That's my third step, or second, whatever. And then my next step is going to be to turn this into e. And for that, I'm going to use the following. Actually, never mind. First, I'm going to multiply both sides by -1 so that we can have an agreement. Don't forget to do it on both sides. And then we're going to change this 2 to an e. To do that, we're going to use the following identity. As you know, any a can be written as e to the power ln a. Therefore, 2 can be written as e to the power ln 2. What is so good about it? Now replace 2 with e to the power ln 2. And don't forget to raise it to the power -x. And of course, we still have -1/4 on the right-hand side because we haven't made any changes. We only substituted this for 2. Make sense? If you understand every step, like clearly, hopefully it's going to be better for you. Now, we're going to go ahead and multiply these exponents, distribute -x times e to the power -x ln 2. If you have ln and x, you want to write the x first because otherwise it's going to look like this. It's not a subtraction, but even if you put parentheses, this looks weird because are you talking about the ln of 2 times -x? No. You're talking about -x times ln 2, which is much, much better. Make sense? Great. Now that we got out of the way, and we are super duper close. Now, what do we want? We want this one and this one to be the same. Are they the same? No, but we're pretty close. All we have to do is multiply both sides by ln 2, and that'll do the job, okay? And of course, you have to multiply both sides by ln 2, otherwise you'll get the wrong answer for sure, guaranteed, right? Now, our expression turned into something much nicer, and for sake of insanity, trust me, it's going to save you a lot of trouble, replace this with t, and do not forget that, okay? So now we have t e to the t equals -ln 2 divided by 4. Okay, you may want to write it that way or not, I don't know. Maybe keep it the same because we'll probably have to play with the coefficients, because if you notice, the right-hand side doesn't look like t e to the t, right? We kind of need to turn it to that thing. And how we do that, that's going to be actually pretty interesting, okay? So, but we got the following. We got t e to the t, which is nice because if we apply Lambert's W function on both sides, and let's go ahead and do that right here to save some space and time. And let's go ahead and apply our super duper Lambert's W function on both sides. So, and this is going to give us t, as you know, this is product log, by the way, is w of -1/4 times ln 2. Now, you want to get the value of t because t is equal to -x ln 2. And of course, once you solve for x, you're going to be, once you solve for t, you're going to be able to solve for x from this equation. But the million-dollar question is, what is this equal to, right? So that's what we need to figure out. Now, if you did know what the answer was, you could probably just figure it out very easily. But in this case, we're going to have to do a little bit more work. So here's what we're going to do. We're going to take this expression and turn it into something like t e to the t or c e to the c. Since c is a constant, this actually fits the bill better. So I can try a couple different things like this. I can write this as -1/2 times 1/2 times ln 2. Then I can pull that 1/2, bring it over here, make it an exponent, and then see if these numbers are going to agree. 2 to the power 1/2 is square root of 2. And as you can see, I want these numbers to be the same, by the way. Even though this doesn't have an e, we're going to be able to take care of that, which I'm going to show you later. Let's not worry about that right now. So my goal is to get something like c ln c, if that makes sense, or a ln a. Then we can turn it into c, okay? But these two are not the same thing. How do we make sure that we can get the same thing from them? Maybe this approach isn't a good one. How about this? -1/8 times 2 times ln 2. If I bring the 2 over here, that's probably not going to be a good thing. By the way, I don't have to keep the negative here. I could also do this. Remember when we had the -1/4, we said, okay, maybe, how about something like this? Would this work? No, because this is still going to give you some type of radical. But it's probably better to keep the 1/2 or any fraction here, because when you move the negative exponent, it's going to give you a fraction as well, okay? Something less than 1. So that should be the goal, but try with different numbers such that this product is -1/4, but you don't want to use 1/2. It didn't work. Maybe something like, and again, our goal is to get -1/4 from here. So maybe I can try something like 1/8, right? And then I should be using a -2 here, right? Okay, that might work. And in that case, we'll be getting something like 2 to the power -2, which is 1/4. It didn't give me what I want. Maybe try something like 1/4 times -1 times ln 2. And then if I go ahead and move this here, 2 to the power -1 is 1/2. It didn't work. Maybe I should go a little deeper. How about 1/16? 1/16 times, what is going to give me -1/4? Of course, it's going to be -4 ln 2. And yes, this does the trick. You know why? Because when I move this -4 here, as you know, the properties of logarithms, right? ln 2 to the power -4, and 2 to the power -4 is actually ln 1/2 to the 4th power, which is 1/16. So this is what I'm looking for, okay? Now, you might be saying, okay, how is this helpful, though? You didn't get t to the t, but you get a times ln a. How is that helpful? Let me show you. Now, 1/16 can be written as e to the power ln 1/16, just like before, times ln 1/16, and this is exactly ce to the c. ln 1/16 times e to the power ln 1/16. In this case, your c would be ln 1/16. And as soon as you apply Lambert's W function on this, because we were supposed to remember, you're going to get ln 1/16 from here. This is your c or t or whatever you want to call it. And on the left-hand side, if you remember, I hope you didn't lose that thing, we had t or -x ln 2. So we can just directly use x, -x ln 2 is equal to ln 1/16. Of course, ln 1/16 is ln 2 to the power -4, which is -4 ln 2, by the way. So now you have -x ln 2 is -4 ln 2, which shows you that -x is equal to -4, which means x is equal to +4. Awesome, right? Now, here's a trick. I'll show you a graph too. Is this the only solution? That's for you to find out, but can I give you a clue? It's not. When you graph, you're going to realize. But why didn't we get the other solution? The answer is buried deep in Lambert's W function. Let's go ahead and take a look at the graph, and we'll finish with that. But before we finish, I want to tell you something else. You could definitely do a guess and check on this problem, particularly in this case, like, okay, looks like x needs to be a power of 2, right? So we can test some numbers. Obviously, something less than 2 is not going to work. X equals 2 is not going to work because that gives you 1 equals 2. So x is probably greater than 2. I'll try 3 and 4. 3 doesn't work because 3 does not equal 2 to the power 1, but 4 equals 2 to the power 2. And this tells you x equals 4 is a solution. What about the other solution? That's for you to find out. Use Lambert's W or the graph or whatever you like. And as you can see here, I'm actually giving you the numerical value, so it's kind of like a giveaway, right, for free, that you get to see both solutions on this graph. And obviously, you can tell because our function, the exponential, is concave up, and y equals x is a linear graph of function. Obviously, they have to intersect at 2 points unless y equals x is tangent to this graph, which is not. Therefore, we get 2 solutions. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out SyberMath, the short channel, and aplusbi, and bye-bye.